Hi and welcome to my maths class. Today we are doing a summary of all the grade 11 probability. Okay, in the grade 11 probability, the first thing that we discussed was dependent and independent events. Independent event says that PA times PB is equal to P of A and B. Now, when they are dependent, when you calculate the P of A and you calculate the P of B, you will see that it does not equal to the P of A and B. Now, the reason for that is because here, on the second event, you usually have a change in the fraction, where independent events means you replace anything that you take out. So if I'm having different color balls and I take out one ball, when I'm done I take it and I put it back. Okay, when you're working with probability, you have your favorable outcomes over your total outcomes. Now what you would notice when they are dependent is that the denominator tends to decrease as you are working or as you are going through the events. So by the second event, the denominator is not always like the first event. If you are doing the same thing, like if I'm taking a ball and I'm taking it out from the bag, if I put it back, then I still have the same amount of balls when I started. But if I don't put it back, then I don't have the same amount. So that is why when you're working with dependent, you see that the probability of A and B is not the same. That was the first thing we discussed. We will do it in more detail when we're doing questions related to this. The second thing you learned was that the probability of A plus the probability of not A is equal to 1. So when we're working, if it is a very large sum, instead of adding all that, we look at what is easier and then we use this formula to accommodate ourselves. Okay, the next thing we did was the tree diagram, the Venn diagrams, and the two-way diagrams, two-way tables. Now, in order to be comfortable with your grade 11 work, you must cover all of this and you must understand it. Besides this, you must be comfortable with all your grade 11 work and you must be comfortable with all your grade 10 work. Okay, let us do examples that are related to all these questions. If you look at this, it says a bag contains 6 red balls, 4 white balls and 5 green balls. A ball is drawn and not replaced. That is important. Now, then a second ball is drawn. Now what happens is, you have 3 branches. You have a red, you have a white and you have a green. Now for the red, you had 6 out of 15. How did I get 15? I added the amount of balls that I had in the packet. For white, I've got 4 over 15. And for green, I have 5 over 15. Now, if I take out one red, remember you're going to do the whole thing again. You're going to repeat the event again. Now, if you think, if you took out a red, then white is going to be the same. See, I'm repeating the same thing, right? I've got red, white and green. Let's work with red. If you took out a red, you had 6. That's what they told us. But now you took out one, so you only have 5 left. How many white do you have? You still have 4. How many green do you have? You still have 5. But now, if there were 15 balls in the bag and you took out one, how many is left? There's only 14. So remember, when you are not replacing, the denominator changed. Let's go to the next one. Now you had 4 white. If you took out a white, so at this stage it's saying, listen, you took out a white. If you took out a white, then instead of 4, you'll only have 3 left. But you still have 6 red and you still have 5 green. Again, it's over 14. Why? you had taken out 1. Now why am I doing 3 branches in the beginning? Because you had a choice to get a red, you had a choice to get a white, you had a choice to get a green. Then you took out 1, and then again you had a choice of getting a red, you had a choice of getting a white, you had a choice of getting a green. Now let's do with the green. Let's do the same thing with the green. You had 5 green, which means now you only have 4. You had 4 white, so it's still going to be 4, and you had 6 red. Now, once you got the tree diagram, how do we get the probability? If they say I want the probability of R and R, it means I'm taking the R and I'm taking the R again. So what do I have? I have 6 over 15 times 5 over 14. That will be the probability of R and R. When it's 2 events, then the formula is the probability of R times the probability of R. Remembering that the second one could have changed. Now why am I saying could have? Because if you had put the ball back, then remember the denominator wouldn't have changed. So our answer is 1 over 7. Okay, so the probability is 1 over 7. Remember, you can use your calculator to solve this. Because it's a multiplication rule, it's called a product rule. You're allowed to use your calculator and give the simplest form. Get the probability of green and white, but in any order. Now remember, if they're saying in any order, that means I must look where do I have white and then green, or where do I have green and then white. Now the probability of green and white. For the first one, I have 4 over 15 times 5 over 14, which is equal to 8 over 105. Then for the next one, I have 5 over 15 times 4 over 14. So can you see I'm working with this probability times this probability, which is equal to 2 over 21. Now because they say anyone, the concept of any works with or. If you remembered from your grade 10 work, I had mentioned that or means take everything. Now when they tell us that it can be in any order, that means it's an or. I can take white and green, or I can take green and white. So I can take white and green, or I can take green and white. So what I'm going to do is I'm going to add the options. So I had 8 over 105 plus 2 over 21. So my final answer would be 8 over 105 plus 2 over 21. Now if they change the question and they said, what is the probability of getting green and white in that specific order? Then the only option we could use was this one here. Because green and then white meant 2 over 21. Then that probability would be 2 over 21. Now let's look at the last one. It says, is P of R and W dependent or independent? R and W. So we're looking for red first, then we're looking for W. So R is 6 over 15. That's the probability of R. And the probability of W is 4 over 15. So we know that R is 6 over 15 and white is 4 over 15. Together, we also know that if I was doing the probability of R and W, so if I was doing the probability of R and W, it would be, now look at your drawing because this is where you mustn't go wrong. You look at your drawing and you see, okay, when it was first R, it was 6 over 15. But look, When it went to W, it became 4 over 14. So I have 6 over 15 times 4 over 14, which is equal to 4 over 35. Now what is P of R times P of W in their absolute original form? Remember, in the original form, it is what they are at very level 1. At the very first level, what are they at that level? And if I take that and I multiply it, I got 8 over 75. You can clearly see they are not equal. So if they are not equal, then we have that P of A times P of B is not equal to P of A and B. Therefore, they are not independent. Let us look at the following question. This question is a Venn diagram. What's nice is they'll always tell you, draw a Venn diagram. So you know exactly which direction you're going. What you need to look at is, how many options are they giving me? Are they giving me 1, 2 or 3? Now if I give you an arm, a leg and a nose, that means I have 3 circles. Okay, so we have the arm, we have the leg and we have the nose. When you are doing these Venn diagrams, the best place to start from is the center. That is the safest place to start from. If you start anywhere else, you start making silly mistakes. Now they tell us 21 broke an arm, 28 broke a leg, 8 broke their noses, 9 broke an arm and a leg, 5 broke a leg and their nose, 6 broke their arm and a nose, 10 did not break any bones. Now not breaking any bones, that's easy to put in because you know, okay, that's not within the circle at all. Now what did you notice that they didn't give us? They didn't give us where all of them are. So basically somebody who broke their arm, the leg and their nose. Now when they don't give us that information, you know that's your starting point. Now they didn't give it to us, so we are stuck. What happens is you immediately put an X there if they didn't give it to you. Now you're moving out. Now when you're doing Venn diagrams, number 1, pupils forget to subtract. Number 2, you forget to total. Those are the 2 most common mistakes. Now what do I mean when I say subtract? Now we're going out. We're looking for where we have an arm and a leg. So let's look for arm and leg. 9 broke an arm and a leg. Now an arm and a leg is this entire block. Can you see? Wherever I'm coloring, that is an arm and a leg. So the whole thing must be 9. Not just this. That's not accepted. Because you know the whole thing has to be 9. So what is this? 9 minus x. So when I total it, 9 minus x plus x equals to 9. So it is 9 minus x. So we are done with arm and leg. Let's look at this one. We need this area. Because remember I told you you work outwardly, right? So we need an arm and a nose. And here they tell us that 6 broke their arm and nose. Now again, you know the entire area is 6. So if I am doing this part, then it has to be 6 minus x. Because when I'm totaling, then it must equal to 6. So 6 minus x plus x gives me 6. Now you're done with arm and nose. Then they say 5 broke a leg and their nose. 5 broke a leg and their nose. So where am I working? Leg and nose is this area. If it's 5, remembering that x and the space here must give you 5, which means that this is 5 minus x. Don't forget the subtract. That is the most common mistake, the subtract. So here we have 5 minus x. Now let's go on. Okay, so we have that the total is 21. We have that the legs, the total is 28. And we have that the broken nose is 8. But now how do we solve for this specific part? How do we solve for that? If you look at that specific spot, how do we find out what it is? Let us say it is y. Now we know y plus 9 minus x plus 6 minus x plus x is going to equal to 21. So what we're saying is that this entire circle, we know that this entire circle is going to equal to 21. Okay, now let's get y to be the subject of your formula. What you're going to do is you're going to take your numbers over. So you got 9 plus 6 is 15. So we're going to have 21 minus 15. And then here you have minus x plus x, which is minus x. If you take it over, it becomes plus x. So we have y is equal to 6 plus x. Normal solve for x, it's similar to that. Making y the subject of the formula means taking everything over. So instead of y, what we're going to write is, we're going to write 6 plus x. So we're not going to write y. We're going to write 6 plus x. Now let's make this side p. Now we know that if I take everything in p, plus I take the 9 minus x, the x and the 5 minus x, then it must equal to 28. So what am I saying? P plus the 9 minus x plus the x plus the 5 minus x must equal to 28. Now if you get p alone, then you're going to end up with x plus 14. So here we know that it's going to equal to x plus 14. Okay, if we make this q and then we take everything in this circle, we know that when we add it, it must equal to 8. So what do we have? We would have had that q plus 6 minus x plus x plus 5 minus x is equal to 8. If you make q the subject of the formula, you're going to have q is equal to x minus 3. Now, when we started, they told us that the total for this entire sample space was 50. So how do I solve x? You can't say, hey, you know what? Just add 21 and 28 and 8 and 10. Doesn't work, because if you just count it already, you can say, hey, but you exceeded it, 20, 40, 49, 59, 67. So you can't just add. What you do know, that if I take all of this, plus I take the 10, it will equal to 50. So let's write it down. We have 6 plus x. So I've taken that one, plus 9 minus x. Then I've got plus x plus 14 plus x plus 6 minus x plus 5 minus x plus x minus 3 plus your 10. Remember, we're talking of the entire sample space, so I need to include the 10. Plus 10 is equal to 50. Now, if you solve, you would have had x plus 47 is equal to 50. That would give us x is equal to 3. Now, we've got x plus 47 is equal to 50, x is equal to 3. Now, redraw your diagram. We know that x is equal to 3. 9 minus 3 is 6. 5 minus 3 is 2. 14 plus 3 is 17. Now, if you check, 17 plus 2 is 19, plus 3 is 22, plus 6 is 28. So L is equal to 28. Then we've got 6 plus 3, which is 9. 6 minus 3, which is 3. And then we've got 3 minus 3, which is 0. If you want to double check, then we can say 9 plus 6 is 15, plus your 3, 18, plus your 3 is 21. And we said that A is 21. We said that L is 28. And if you look at N, it's 8. 3 plus 3 plus 2 is 8. Plus we have our 10 outside. Now let's go to the other questions that they may ask you related to this. Okay, they told you draw a Venn diagram. Now, when they ask you to draw a Venn diagram, they didn't tell you, hey, solve for x. But in order to do the others, you have to solve for x. What is the probability of a broken arm? Now that you could get simply from looking at your information. A broken arm is 21 over 50. What is the probability of a broken leg? A broken leg was 28 over 50. An arm or a leg. Now you see how that becomes more challenging, because now you don't know what's an arm or a leg. Okay, but if you look at your drawing, an arm or a leg, or means everything. So I'm going to take everything here. Can you see? So we've got 9 plus 6 is 15, plus 3 is 18, plus 3 is 21, plus 2 is 23, plus 17 is 40. If you take 40, then your answer is 40 over 50. But what learners do is they say, okay, what's 21 plus 28? Oh, it's 49. So my answer is 49. That will become a problem, because you need to know that it's overlapping and you have to calculate x before you can actually answer number 4. Now, the next one is interesting. P of not an arm or a leg. Now, if you already got what is an arm or leg, it's 40 over 50. So, P of an arm or a leg is 40 over 50. So, if I want the probability of not an arm or a leg, 1 minus 40 over 50, which is equal to 10 over 50. Then we have P of not a nose. So if you go to your Venn diagram, now if I want not a nose, I must add all of these. But what if I got P of a nose? P of a nose, we know, is 8 over 50. So P of not a nose would be 1 minus 8 over 50, which is equal to 42 over 50. Right, now for the last part of our probability. Okay, a survey shows the following information regarding how people spend their weekend. What you need to know how to do is to read this drawing. So if I say sleep and male, then you're going to take your hand, male and sleep, and see where they're meeting. So it would be at 13. Also, what you need to know is that the total for the probability is the total of the entire event, which is the last block on your right hand side. Now, determine the probability that the person is a male. If I want a male, I'm looking at the total. So I want male and I want total. So where are they meeting? At 83. So the probability is 83 over what is my total? 180. Be careful. Most of the people don't know where to look for the total. Now, what is the probability of fishing? They're not telling you that it's a male or female. They're simply telling you fishing, which means the total of fishing is 98. So the probability is 98 over 180. Then the next one is, what is the probability of fishing and a female? So I'm going to fishing, I'm going to female, and they are crossing at 52. So the probability is 52 over 180. Okay, now let's look at the last one. Is being a female and sleeping independent events? First, we need to look at the probability of being a female. If you look, being a female is 97 over the total, which is 180. What is the probability of sleeping? Sleeping, the total for sleeping is 20. So the probability of sleeping is 20 over 180. Now what is the probability of being a female and sleeping? Being a female and sleeping, we are crossing over at 7. So the probability of being a female and sleeping is 7 over 180. Now be careful. Very often we get 7 over 20. They use the wrong total. The total, remember, is 180. Now, for it to be independent, P of F times P of S is equal to 97 over 180 times 20 over 180. 97 over 1620. You can clearly see that the answers are not the same. Therefore, is being a female and sleeping independent? It is not independent. Thank you for watching.